If you ask my parents, they'll tell you that I studied dirt. And they're not that far off, actually. My research is focused on understanding sediment transport, and basically that's how mud or sand moves in the environment. And in the delta, we care about sediment transport because, as you can imagine, a lot of the times these sediment particles carry contaminants. And so where these sediments end up, that's where your contaminants will end up as well. And at the same time, if you have a lot of sediment in resuspension, it's going to limit the amount of light that can come in. And so if you have fish or phytoplankton that needs light to grow, then you're in a bit of a trouble. My research has two aims. One is to really advance the basic sediment science, so focusing on the particle dynamics, how they come together and break apart. And the second is actually utilizing information that we already have in the monitoring observations and try to track peak sediment events before and during and after the drought. And we do a lot of this work by throwing a lot of fancy electronics in the water carefully. And we get these observations, and our preliminary results show that, at least at the particle scale, that it's really controlled by the intensity of your flow. The next part of my project that I'm really excited about is really diving into that monitoring results and try to track the peak turbidity and sediment events and do a comparative analysis of what happens before and after the drought and evaluate the implications on water quality.